Hi, NR here. I am happy to announce that mobile application is released and it is available in Google Play Store. Silver Valley Academy. Synopsis, shortcuts and 100 plus multiple choice questions are discussed in every chapter. And this is equivalent to 10 to 15 classroom hours. These questions are on par with Karnataka CET, COMEDK, PESSAT and NEET. Silver Valley app link is in the description box. Download, subscribe and share to encourage this new initiative. Thank you. Let us work on synopsis of first chapter, electric charges and fields. First concept. Product of the charges Q1, Q2 greater than 0. Second, Q1 into Q2 less than 0. What is the nature of charges if Q1 into Q2 greater than 0? Nature of charges is like. They are like charges. Plus and plus greater than 0. Minus into minus greater than 0. So what is the nature of charges means like charges. Like charges. And what is the nature of force? Since they are like charges, it is repulsive. Repulsive force. If product of two charges is less than 0, then the nature of charges is unlike. Unlike charges. Unlike charges means one of them is plus, the other is minus. Then product of these two is less than 0 or minus plus less than 0. So unlike charges and it is attractive in nature. Attractive. In most of the questions they just mention attractive force or repulsive force. Attractive force or repulsive force means they are indirectly mentioning the nature of charges. So we have to catch that point. Okay. Coulomb's law. So force of attraction or repulsion is directly proportional to product of the charges, inversely proportional to square of the distance between them. So constant of proportionality K. And F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. If only epsilon naught is there, then this is force between charges when they are separated by air or vacuum. Okay. And if this is a vector quantity, then I have to write R cap. Now, force in air equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. If the two charges are separated by some medium, force in medium equal to 1 by 4 pi epsilon naught epsilon R Q1 Q2 by R square. So this is force in medium. Force between two charges in air to force between same two charges separated by same distance in a medium is epsilon R. This epsilon R is called relative permittivity. Relative permittivity. Relative permittivity. And relative permittivity epsilon R is always greater than 1. Electric field is the region around a charge where a test charge can experience force. These are electric field lines. So this represents uniform electric field. If lines are represented by equidistant parallel lines like this, then this represents uniform electric field. So this means there is a sheet of charge another sheet of charge. If one sheet is positively charged and the other is negatively charged, then there exists electric field. Electric field is from positive to negative. Okay, like this. So this small region is the region of uniform electric field. That uniform electric field is this. So whenever you see electric field like this, you should imagine that this region is the region between two charged plates. Next, if there is a positive charge in the electric field, then this experiences force in the direction of the field, force. Whereas a negative charge experiences force against the direction of the field. And force on the charge Q in the electric field is Q into E. The direction of electric field is the direction of force. Direction of electric field is the direction of force for a positive charge. If this is negative, then direction of this is opposite to the direction of this. That is in this case. Okay. Next, if there is a point charge. If there is a point charge, then electric field at a point due to this point charge separated by some distance r is electric field equal to 1 by 4 pi epsilon naught q by r square. So this is the expression for electric field, 1 charge by distance square. And how electric field is defined? Electric field is defined as the ratio of force per unit charge. To be more precise, electric field equal to limit of force by charge as the charge tends to 0. The test charge tends to 0. Okay. F is a vector quantity, therefore electric field is also a vector quantity. If this is positive charge, then let us keep a test positive charge. This test positive charge will move in this direction. Then that is the direction of electric field line due to this charge, capital Q. Okay. Now keep this test charge here, then this test charge moves in this direction. Therefore, this is the direction of electric field at this point. If there is a charge and this is point P at a distance r, this charge is Q, then electric field is given by 1 by 4 pi epsilon naught Q by r square. So this electric field is electric field when the charge is in air or vacuum. Suppose if the charge is in a medium, electric field in a medium is 1 by 4 pi epsilon naught epsilon r Q by r square. See, whenever medium is involved, we have to introduce this term epsilon r, and electric field in air to electric field in a medium is equal to epsilon r. So this ratio is epsilon r. So just like force, this ratio is epsilon r. So the ratio of electric field at a point due to a point charge in air to the electric field at the same point due to same charge separated by same distance in a medium is epsilon r, relative permittivity. And this is always greater than 1 means electric field in air is always greater than electric field in a medium. Electric field in air is always greater than electric field in a medium. Third concept, electric dipole. Two equal and opposite charges separated by small distance constitutes a dipole, minus q plus q. Distance between the charges is taken as 2a or 2d. This is center of the dipole, O. Then this distance is a, this distance is another a. Dipole moment dipole moment denoted by P is given by charge, magnitude of each charge into distance between the charges. Dipole moment is a vector quantity, therefore P cap, unit vector. What is the direction of P cap means? The direction of P cap is from minus Q to plus Q along the line joining the charges. So we should know the direction, how to find direction of dipole moment, and thereby we can find out angle between electric field or something else with respect to electric dipole. Observe, this is uniform electric field and here is a dipole. Plus Q and minus Q. This angle is 30 degree. Electric field is E. Then the angle between dipole moment and electric field means first find out the direction of dipole moment. Dipole moment is from minus Q to plus Q, nothing but this direction. Electric field is this. Therefore, this angle is the angle between dipole moment P cap and electric field. So if we neglect the direction of dipole moment, then we are tend to take 30 degree as the angle between dipole moment and electric field. That is not correct, isn't it? So this is the direction of dipole moment. Observe one more diagram, one more case. So this is minus Q, plus Q. So if this angle is 30 degree, then direction of dipole moment is from negative to positive along the line joining the charges. Now in this case angle is 30 degree, whereas in this case angle is 180 minus 30. 180 minus 30 is 150 degree. Okay. So we should be careful with direction of dipole moment. The direction of P cap is the direction of P and unit is Coulomb meter. Next, electric field at a point due to a dipole. If this is a dipole, minus Q and plus Q, center of the dipole, this is axis of the dipole, some point P at a distance A from R from the center. So this distance is R. This is R. Direction of dipole moment is from minus Q to plus Q. So this is the direction of dipole moment. This positive charge is closer to this point. Therefore, effect of positive charge is more. So this is E plus. Negative charge is far away from P compared to Q, capital, compared to this charge. Therefore, this is the direction of electric field due to negative charge, E minus. So resultant of these two will be in the direction of the greater vector. So this is the resultant electric field at this point due to these two charges. Now these two are not required. Look at the directions of P cap and E. These two are in the same direction. So electric field at any point on the axis of an electric dipole is constant. This constant is 1 by 4 pi epsilon naught into 2 P R by R square minus A square whole square. There is plus sign here. Direction of P cap is the direction of E. Direction of P is the direction of E. For a short dipole, short dipole means this R should be very much greater than this A. Distance between these two is A. R very much greater than A. then electric field is given by constant 2p by r cube. First thing, we should observe that direction of p is the direction of E. Second thing, electric field is inversely proportional to r cube. Why we need this relation 1 by r cube? Observe this example. This is an electric dipole, okay, minus q plus q, and electric field at a distance r from the center of the dipole is E, okay. What is the electric field at a distance if r is doubled? So this is r. If r becomes 2r, if point P is at a distance 2r, what is the new electric field? Okay. See, distance is doubled. To decide the new electric field, old electric field divided by r cube. R cube is 2r. So 2 cube. 2 cube is 8. So electric field by 8. So this is the electric field when the distance is doubled. Recall electric field at a point due to point charge. There, electric field is proportional to 1 by r square. In this problem, if you judge electric field proportional to 1 by r square, then you will be wrong. 2 square will be 4. But in the case of dipole and point, electric field is inversely proportional to r cube. Okay. So first thing, you should know the direction of electric field with respect to dipole moment. Second, electric field inversely proportional to r cube. Electric field at a point on the equatorial plane. This is an electric dipole, minus q plus q, center of the dipole O, this distance is a, this is also a. Direction of dipole moment is from minus q to plus q, minus q to plus q, this is p cap. This plane is called equatorial plane. Why this plane is called equatorial plane? If you consider any point on this plane, okay, this point, then this point is equidistant from these two charges. That is why this plane is called equatorial plane. And if you draw any line on this equatorial plane, then that is called equatorial line. So in multiple choice questions, sometimes you can see equatorial plane, sometimes equatorial line. A line on an equatorial plane is a equatorial line, okay, right. Now this is the equatorial line. Electric field at this point. Because of negative charge, direction of electric field is towards. Because of positive charge, electric field is away. Resultant of these two electric fields will be in this direction. So this is the electric field at this point P at a distance r from center of the dipole. So this is electric field due to negative charge, electric field due to negative charge, electric field due to positive. Resultant of these two is this, and direction of this electric field is opposite to the direction of P cap. So this you should observe, okay. Now expression for electric field is constant minus P by r cube, r square plus a square whole to the power of 3 by 2. This is electric field at any point on the equatorial plane. For a short dipole, r is very much greater than a. Neglect a, square root get cancels, r cube. So electric field equal to minus constant P by r cube, okay. So this is the expression for electric field at a point on the equatorial plane of a short dipole. Again, in this case, electric field is proportional to 1 by r cube. Second thing, electric field at a point on the axis is equal to 2 times electric field at a point on the equatorial plane with negative sign. These two directions are opposite, and electric field at a point on the axis is twice the electric field at a point on the equatorial plane. Recall, in the previous equation there was 2 here. Now 2 is absent. Therefore, we can get this relation, this, as well as we can say that electric field is opposite to the direction of dipole moment, equal to P cross E. Torque is P cross E. This is uniform electric field. This is a dipole, minus Q. This is plus Q. Minus Q experiences force against the direction of the field, like this. Plus Q experiences force in the direction of the field. Force is F equal to Q into E in this direction. F is Q into E in this direction. Something like this. Force on this is along the horizontal. Force on this is also along the horizontal. As a result, there is rotational motion. Rotational motion is due to torque, and the torque is given by P cross E. And you know that cross product of two vectors is not commutative. Not commutative means tau equal to electric field cross P. And you also know that tau equal to electric field dipole moment with negative sign. If this is P cross E, then minus E cross P. Okay, this is from vectors, basics of vectors. So you can learn basics of vectors in motion in a plane chapter and work energy power chapter in the first PUC or in 11th standard portion. Okay. What is the direction of torque? Direction of torque is from P to E, perpendicular to P and E. So torque is perpendicular to both P and E. What is the direction of dipole moment? Dipole moment is from minus to plus along the line joining the charges. So this is P cap. Electric field is this. To find the direction of cross product of two vectors, use right hand. Okay, use right hand. Let curvature of right hand fingers. Please observe right hand. Curvature of fingers should be from first vector to second vector. See, first vector P. P. Second vector is E. Don't bend like this. It should be like this, isn't it? So if you bend like this, after that open the thumb. Thumb gives the direction of cross product of these two vectors. In this case, thumb is into the plane. So the direction of dipole moment is perpendicular and into the plane. Perpendicular and into is represented by this symbol. So this is tau cap. Though it rotates in the clockwise direction, that is not the direction of torque. This is the direction of torque. First vector to second vector, P to E. Open the thumb. Thumb points inward. Therefore, tau. Okay, good. So we learnt few things. Direction of rotation is not the direction of torque. Second, it is always P cross E, not E cross P. If you change the direction, if you change the orientation, if you reverse the order, then you should put a negative sign. So instead of this, try to use P cross E. Okay. And what is the unit of torque? Newton meter or joule. If torque is P cross E, then magnitude of torque is P E sin theta, isn't it? P E sin theta. If theta 0 or 180, then torque is 0. Sin 0, 0, sin 180 is also 0. If theta is 90 degree, then torque is maximum, and maximum torque is P into E. Therefore, this can be minimum, tau minimum. Tau maximum is P into E, minimum is 0 degree. So, for questions like for what angle torque is minimum, for what angle torque is 0, for what angle torque is maximum. So, we can depend on this. Cross product of two vectors means sine function. Dot product of two vectors means it is cos function. Okay. Electric flux. Electric flux is the number of field lines passing through some area. So, electric flux is equal to dot product of electric field and area vector, where A is area. This is equal to EA cos theta. Since it is dot product, it is cos theta. And for phi, you can also write A dot E. Dot product follows commutative law. So, phi is also equal to A dot E. Okay. Area vector dotted with electric field. Now, what is area vector? If this is a cube, this is a cube. Length of each side is L. Depth is also L. Then area of this is length into breadth. L into L, L square. So, area is L square. That L square is represented by this vector. So, this is the area vector of this shaded face. Now, observe the top face. Area of this is also length into breadth. L into L is L square. So, area of this is same as the area of this. Therefore, draw this vector. Area of this equal to area of this. Therefore, keep length same. Now, how about this front surface? Area of this front face is also L square. Therefore, this is represented by this vector, which is perpendicular to this face. Perpendicular to the face means draw a circle and draw one line. If vector is perpendicular and out of the plane, dot. Vector is perpendicular and into the plane, into. Okay, into with a circle. Now, if there is an irregular surface, to draw area at a point, you should consider small region. To this small region, which is almost flat, if there is an irregular body, small region which is almost flat is taken as the reference, and area of this flat surface is taken as area drawn at this point. That area should be perpendicular to the surface. Okay. Again, to draw area vector at this point, consider small region which is almost flat. To that small flat region, draw the area vector. So, this is how we can draw area vector. This is some area, circular area. This circular area is represented by this vector. So, this is the area vector A. Angle between area vector and electric field is 0. So, here theta equal to 0. Cos 0 is 1. Therefore, flux equal to E into A. And this flux is maximum. So, maximum flux is observed when angle between area vector and electric field is 0. You should always search for the angle between area vector and the electric field. Observe, plane of the circle is perpendicular to electric field. Again, plane is perpendicular to electric field. Let me write plane perpendicular to electric field. What is the angle means? Angle is not 90 degree, angle is 0 degree. Okay. In multiple choice question, it is common observation. So instead of giving theta, angle between area vector and electric field, most of the cases they give angle between plane and the electric field. Okay, right. Next, this is the area. Then this area is represented by this area vector. So angle between this area vector and electric field is 90. So theta equal to 90. Theta 90 degree means cos 90 is 0. Then flux equal to 0. If we keep a circular coil like this and electric field is along the horizontal, so no line of force can pass through this. It cannot simply change the direction and pass. That is the meaning flux equal to 0. Next, this is the circular area. Area vector is perpendicular and outward. Perpendicular and outward. So angle between this area vector and electric field is 90 degree. Again, flux equal to 0. Suppose this is the coil, plane makes an angle theta with respect to electric field. Understand? Plane makes an angle theta with respect to electric field. So this angle is theta. Then what is the angle between area vector and electric field means? Draw the perpendicular to this circular face, draw the area. So this is area vector, this angle matters. So this is the angle between electric field and the area vector. This is A. To avoid confusion, let me denote this by delta. Okay. If delta is the angle between plane and E, this is delta. Then this angle is 90 minus delta. This 90 minus delta is theta. Okay. If this is 30 degree, then this angle is 60 degree. So 60 degree is wanted for the equation. So this is related to flux. Next, Gauss theorem. Gauss theorem says electric flux is equal to Q by epsilon naught. Electric flux through any closed surface is 1 by epsilon naught times total charge enclosed by the surface. This is some surface, closed surface. If it has 20 electrons, because of electrons negatively charged, electric field lines are inward. Then flux is negative. Negative flux means inward flux. If this surface has 50 protons, protons are positively charged. So the direction of electric field is outward. Then flux is with positive sign. If some closed surface has 25 atoms, atoms are electrically neutral. If atoms are electrically neutral means this charge is 0. Therefore, flux equal to 0. Flux 0 means number of outward field lines equal to number of inward field lines. Nothing but total flux is 0. If there is a dipole, minus q and plus q, then also flux is 0 because net charge of the dipole is 0. There is negative sign, therefore there could be some inward flux, and this inward flux will be equal to outward flux. That is the meaning of net flux equal to 0. Net flux equal to 0 doesn't mean that there is no inward flux or outward flux. Total flux is 0. See, this region is closer to negative charge, therefore inward flux is more. This region, outward flux is more, but this outward flux is equal to inward flux, therefore resultant flux equal to 0. That is the meaning of this. Okay. So Gauss theorem is true for any shape. It could be sphere, it could be cube, it could be any regular shape. But what matters is how much charge is enclosed inside matters. Electric field due to a thin sheet of charge. If this is a thin sheet of charge, say positively charged, then electric field at this point is always perpendicular and away because of positive nature, away, and this electric field is always perpendicular to the plane of the charge. Okay, electric field is always perpendicular. Second thing, electric field at this point is given by sigma by 2 epsilon naught. So electric field at a point due to thin sheet of infinite area. Infinite area, why we should consider infinite area means, if area is large, then at the edges electric field is not uniform. So we can avoid non-uniform region. So electric field here is sigma by 2 epsilon naught. And what is sigma? Sigma equal to charge by area. Charge by area or small charge by small area. Okay. This ratio equal to this ratio means this charge density is uniform. Next, if point P is shifted, this is point P. What is the electric field at this point means, again sigma by 2 epsilon naught. So this electric field is independent of distance. This electric field doesn't depend on the distance. If distance is doubled, electric field remains same. This is a thin sheet of charge, plus of infinite area. Electric field is sigma by 2 epsilon naught. Because of thick sheet, electric field at some point is sigma by epsilon naught. This is thick block. This is thin sheet. So this is there in NCERT, and this is extension of this result. Okay. And if electric field is due to positive, away, electric field is due to negative means towards. If this is negative, okay, so we should draw electric field towards, but that electric field should be perpendicular to the surface. Electric field due to line of charge. If this is line of charge of infinite length, positively charged, so electric field at some point at a distance r from the charge. Since it is positively, electric field is away, and this electric field should be perpendicular to this line of charge. First thing perpendicular, second is away because of positive. Okay, and electric field at this point is given by constant 2 lambda by r. This constant is 1 by 4 pi epsilon naught 2 lambda by r. And what is lambda? Lambda is charge by length, or else small charge by small length. If small charge by small length is equal to total charge by total length, then this is uniformly charged. Okay. So this is electric field, and observe, electric field is proportional to 1 by r. Electric field is proportional to 1 by r. Earlier we have seen inversely proportional to r square. Some other case proportional to inversely proportional to r cube, but in this case 1 by r. So you should read the condition carefully, then decide this. Okay. Electric field due to a charged shell. This is a shell. Shell means inside hollow, it is charged. Center of the shell, radius is r. If this is point P, at a distance small r from the center to point P is small r, then electric field is given by 1 by 4 pi epsilon naught total charge Q by R square. So here this is the charge surface. This distance, you should not consider this distance, okay? You should consider the distance as though the entire charge is concentrated at the center. Therefore, electric field is 1 by 4 pi epsilon naught Q by R square. What is the electric field on the surface means? E equal to 1 by 4 pi epsilon naught capital Q by R square. Q by R square. R is radius. So effectively it is the distance from the center. At a point on the surface means distance from the center is radius. At a point outside means distance from the center is R. Now what is the electric field inside the conductor means electric field is 0. So this is true only for a charged shell. Shell means empty, hollow inside. So 0 inside, on the surface this electric field with R square. Outside, don't consider from the surface, you should consider distance from the center of the shell, okay? That is this equation. So these are the equations that are there in NCERT syllabus. In the next session, let us go through few shortcuts and mathematical tools means which are required to solve problems in electrostatics, nothing but electric charges and fields.